Part 3. Directions. In this part, you will hear 3 talks or lectures. The talks or lectures will not be repeated. There are 5 questions for each talk or lecture. For each question, choose the right answer, A, B, C, or D. Then, on the answer sheet, find the number of the question and fill in the space that corresponds to the letter of the answer you have chosen. Questions 21 to 25.
Listen to a lecture in an American history class.
First, you have some time to look at questions 21 to 25.
Today we're going to talk about the last monarch to rule land that today makes up part of the United States. This last monarch was a queen, and she was named Queen Liliuokalani of Hawaii. To understand Queen Liliuokalani's situation, I'm going to give you some background about the history of Hawaii before I discuss Queen Liliuokalani. I'm going to be talking about 2 people today in addition to Queen Liliuokalani. These 2 people are Captain James Cook and King Kamehameha. The reason I'm going to talk about these 2 people is, of course, that they'll help you to understand Queen Liliuokalani and the situation in which she found herself. So, first of all, let's talk about Captain James Cook. You must be familiar with Captain Cook. Captain Cook arrived in the Hawaiian Islands in 1778 and gave the islands the name Sandwich Islands in honor of a British nobleman, the Earl of Sandwich. When Captain Cook arrived in the islands near the end of the 18th century, the islands were not a single unified society. Instead, various islands in the chain were under the control of different native kings. The next person we're going to look at is King Kamehameha. Kamehameha spent almost 30 years uniting the Hawaiian Islands under one ruler, and by 1810, only a few decades after Captain Cook's arrival, all of the islands were united under this one king, King Kamehameha. King Kamehameha was the first ruler to reign over all of the islands together. He ruled over all the islands together until he died in 1819. A number of other kings of the Hawaiian Islands followed Kamehameha during the 19th century. Now we'll discuss Queen Liliuokalani, the last monarch of Hawaii. Liliuokalani became queen after her brother, King Kalakaua, died in 1891. Liliuokalani was the first and only female monarch to rule the Hawaiian Islands, and she was the final monarch of Hawaii. Liliuokalani became queen during a period when a large percentage of the population believed that it was better to have a democratic government than a monarchy. Liliuokalani refused to consider ending the monarchy, and also refused to consider limiting the power of the monarchy and initiating a democratic government. In 1893, 2 years after she became queen, she developed a constitution granting complete power to the monarch. At that point, she was removed from the monarchy. Over the next few years, there were a number of plots to try to reinstitute the monarchy. By 1898, Liliuokalani had renounced her claim to the royal throne of Hawaii. She received a pension from the government and returned to her royal estates, where she lived out her life for the next 20 years with the title of queen, but without the authority as the last monarch of the Hawaiian Islands. I know that the Hawaiian names can be a bit difficult to remember, but I hope you got the important main points. That it was King Kamehameha who unified the Hawaiian Islands under one monarch, And it was Queen Liliuokalani who was the final monarch of the Hawaiian Islands. That's all for today.
What does the lecturer mainly discuss? Why does the lecturer most likely mention King Kamehameha and Captain Cook? What does the professor say about James Cook? What did Liliuokalani believe, according to the professor? Which of the following did not happen to Liliuokalani?
Questions 26 to 30.
Listen to a lecture in a science class.
First, you have some time to look at questions 26 to 30. Now, listen carefully and answer questions 26 to 30.
Today, I'll be talking about an accident at a nuclear power plant. The accident I'll be discussing is the one that occurred at 3 Mile Island in 1979. This was an accident that, while it was very serious, was not as catastrophic as it could have been. By the end of the lecture, you should understand what factors contributed to the accident there. Now you can see 3 Mile Island in this photograph. The nuclear reactor at 3 Mile Island is in the middle of a river in the state of Pennsylvania. This nuclear reactor has 2 PWRs, which means that it has 2 pressurized water reactors. The problem that occurred in 1979 was in the number 2 pressurized water reactor. Now we're going to discuss what happened in the number 3 reactor. Oh, excuse me. Did I really say that? There are only 2 reactors, and the problem was with the number 2 reactor at 3 Mile Island. The important thing to understand about this accident with the number 2 reactor was that there was a series of problems rather than a single problem. The series of problems occurred in the water cooling system. The initial problem was that a cooling system valve stuck open and cooling water ran out. Now, unfortunately, the problem didn't end when the cooling valve was stuck open, because operators misinterpreted the instrument readings. They knew there was a problem. Let me repeat this because it's important. They did know there was a problem, but they were mistaken about what the problem was. They thought the cooling system had too much water rather than too little water. Because they thought there was too much water, they shut off the emergency cooling water. As a result, there was no water to cool the nuclear reactor. Now, there wasn't a complete nuclear meltdown when the emergency cooling water was turned off, but there was a partial nuclear meltdown. A nuclear meltdown would occur if the uranium in the fuel core melted completely. In this situation, heat built up in the fuel core until the uranium began to melt, but it didn't melt down completely. I hope you understood the series of events that led to the problem at 3 Mile Island. One that, while serious, could have been catastrophic. It all started with the stuck valve in the cooling system and was exacerbated by the misinterpreted readings and the improper shutdown of the emergency cooling system. Fortunately, the meltdown that did occur was only partial and not complete.
What is the main topic of the lecture? How many pressurized water reactors are there at 3 Mile Island? What does the lecturer say about the PWRs during the accident? Did each of these happen during the accident discussed in the lecture? What is stated in the lecture about a complete meltdown? How does the lecturer seem to feel about the accident at 3 Mile Island?
Questions 31 to 35.
Listen to a lecture in a geology class.
First, you have some time to look at questions 31 to 35.
Good morning, class. Today, we're going to look at the 3 basic cave structures: sea caves, lava caves, and solution caves. As you may have guessed by the names, the cave structures are named for the process that formed them.
Excuse me, Professor, but can you please repeat that? I didn't quite get it.
You bet. I don't want you to miss it because it's important. What I said was that we'll be talking about the 3 basic cave structures and that the names of the different types of caves are actually derived from the process that formed them. You'll see what I mean after I finish talking about different types of caves and how they're formed.
Okay, thanks.
No problem. Now let's look at this picture of a sea cave. Sea caves are found along rocky shores. Sea caves are formed when pounding water washes away areas of rock, creating a cave. The cave in this picture is one of the most famous sea caves, the Blue Grotto on the Isle of Capri. Have any of you ever been there? None of you? Oh, that's too bad. It's gorgeous. Okay, now let's look at a lava cave. Lava caves form during volcanic eruptions, when the outer surface of flowing lava cools and the lava underneath remains hot. The hot lava below continues to flow and leaves a lava tunnel or lava cave underneath. This picture shows one of the approximately 300 lava caves in Lava Beds National Monument. What does it look like to you? Have you ever seen any place that looks like this? It certainly looks like volcanic areas of Hawaii, and you might expect to find this monument on the volcanic islands of Hawaii. But it's not there. It's actually in Northern California. Okay, now, let me go back to my main point for just a moment. Remember I said that cave structures are named for the process that formed them. Have you understood this in terms of the first 2 types of caves, the sea cave and the lava cave? Well, the same concept applies to the last type of cave structure I'm going to talk about now. Here's a solution cave, which is the most complicated type of cave structure. You can see that this kind of cave has the stalagmites and stalactites that most people picture when you talk about caves. Now, what does this picture show? Does anyone recognize it? Yes?
It looks like Carlsbad Caverns.
That's exactly right. This picture shows the Carlsbad Caverns in New Mexico, and this is one of the most famous American solution caves. A solution cave is formed in areas with a large amount of limestone, marble, or dolomite. Surface water works its way into tiny cracks in the rock. As the surface water trickles through soil, a mild acid is formed, and this mild acid is a solution that creates this type of cave. Over thousands of years, this acid solution dissolves the limestone or similar rock. And what do you think happens as a result? Well, this causes passages and chambers to form underground. If the water table drops, or an earthquake lifts the cave up, the water drains out. Rainwater then continues the process by seeping through cracks into the rocks. At this point, the dripping or flowing water begins to form the marvelous structures found in solution caves, and entrances may develop. These caves usually have very few entrances. An earthquake can lift the cave to the surface, opening the cave. Sometimes land over a solution cave collapses to create a sinkhole entrance. A solution cave can also develop an entrance as soil erodes from a hillside, or as a spring flows from the cave. Now, what's very important to understand from all this is that this type of cave is a very complicated cave structure, and I think you see that. I think you also see that it's called a solution cave because it's an acid solution that forms it. Okay, that's all for now. Next week, we'll discuss speleothems, the beautiful structures that form from various crystal deposits in solution caves. The most famous of these are, of course, the stalagmites and stalactites. See you next week.
What main point does the professor make about various types of caves? Listen again to part of the passage. Then answer the question.
Excuse me, Professor, but can you please repeat that? I didn't quite get it.
You bet. I don't want you to miss it because it's important.
How does the professor seem to feel about answering the student's question? Which caves are not discussed in the lecture? What is stated in the lecture about where the caves are found? What is not a usual way for a solution cave to develop an entrance?
That is the end of Part 3. Now, you will have 7 minutes to transfer your answers to an answer sheet.